Energy is the currency of the universe, and the ability of humans to harness it is what allowed us to progress through these ages. Such an important part of the universe ought to be learned about, and so today, that is what we will do. Unfortunately, energy does not have a clear definition. It is most commonly defined as the ability to do work or produce heat, but those are just two of the many forms of energy. But it's a starting point, so let's define these two things. Work is energy associated with motion, or mechanical energy, and can be thought of as the transfer of energy via a force that acts over a certain distance. A common way to express work is with kinetic energy, and that is energy associated with speed. I'm sure that as someone who's been alive on this planet for a non-zero amount of years, you have some intuition for heat and temperature. We ought to make clear the difference between the two. Heat is a measure of the total thermal energy, while temperature is the measure of the average thermal energy. For example, if we were to compare a boiling tea kettle with an iceberg, the tea kettle will have a higher temperature, but the iceberg will have more heat. This is because the iceberg is larger, so even though each individual molecule has less energy, the iceberg as a whole has more. Let's look at heat a little more in depth. Any atom or molecule above absolute zero will at least vibrate, and this gives them energy. These vibrations are directionally random, and so they do not cause the object to move. The higher the temperature, the faster the vibrations will be, as can be seen in this graph. Although this is a general term, potential energy is energy associated with position or state. For example, a ball on top of a hill has gravitational potential energy. It should be noted that potential energy does not mean the ability to become energy, it is energy. And we will soon see how potential energy manifests in chemistry. Let's define some basic rules for it. It should be noted that each of these could have a whole college course dedicated to them, but we will just give a basic explanation here. The first law of thermodynamics says that energy can be neither created nor destroyed. This is basically saying that the energy of the universe stays constant. It can, however, be transformed from one form to another. The law of thermodynamics states that the entropy of the universe always increases. Entropy is a measure of disorder, and so this law is basically saying that the disorder of the universe always increases. If we compare work to heat, we would find heat is much more disorderly than work, because heat is the result of random vibrations, while work is directional. When energy is lost, it means that a useful form of energy is being converted into a not so useful form, and very often this not very useful form is heat. An example of a force that converts work to heat would be friction. A chemical bond is a result of the attractions between atoms. When a bond is formed, it means that the molecule is more stable than the individual atoms. As such, the potential energy decreases. However, not all bonds are created equal. Some are much more stable than others. Let's look at the combustion, or burning, of methane, which has formula CH4. The net reaction is that methane reacts with oxygen to form water and carbon dioxide. But let's look a bit more deeply into what actually is going on. Since there are bonds holding the CH4 together, it will not combust spontaneously. However, if enough heat, or a spark, is applied, the bonds could break. Now, the lone atoms are very unstable, and since the oxygen in the air reacts readily, it forms the very stable compounds of H2O and CO2. The bonds holding the water and carbon dioxide together are much stronger than the bonds holding the oxygen gas and methane together, and therefore would have lower potential energy. This potential energy has to go somewhere, and in this case it is released as heat. And the fact that reactions can release energy is being used to power modern society. And the fact that you are watching this video means that you are benefiting from these processes, and so I think it's appropriate that you learn a bit about them. At the moment, the most common way to generate electricity is with fossil fuels in most countries. Fossil fuels are mainly hydrocarbons, just like methane, and a similar combustion reaction is used to generate energy. So how do we go from heat to electricity? Well, We use a method that was created in the Industrial Revolution and is still being used today. The heat will be used to boil water and turn it into steam. Then the steam will spin a turbine, which is hooked up to a generator. The turbine and generator will have coils of wire and magnet, which will cause an induced electric current when spun. This induced current is what your electricity is. As such, the quest for better energy has been ongoing. One idea was to use hydrogen gas as a fuel. However, that is faced with its issues. It is both difficult to generate and store hydrogen gas. These are some of the issues that researchers are faced with. But if we can figure out solutions, then perhaps we will have an economical and sustainable alternative to fossil fuels. To harness energy efficiently has been an issue since the dawn of our species, from using our muscles and the muscles of other humans and animals to grow crops, fire to protect ourselves and create stronger tools, to the Industrial Revolution and harnessing chemistry to power our world, to today, where the issue has expanded to not just efficiency, but sustainability. How we can continue to live in this highly advanced world while not jeopardizing a future is a question that scientists are working on today and will probably continue to work on for many generations to come. We learned about energy, specifically work and heat, as well as potential energy. We learned about the laws of thermodynamics and how they impact energy and how energy works. We also learned about chemical energy. We learned that potential energy is stored in chemical bonds, and chemical reactions can be done to release that energy. We also learned about sources of energy in the form of fossil fuels, as well as a potential future source in hydrogen gas. I look forward to seeing you next week.